Hello students, welcome back to our YouTube channel Geeks for Geeks, Gate Computer Science and Data Science. So in this video we are going to discuss system of linear equation and specifically non-homogeneous system of linear equation. So in last class we have discussed about rank of a system of linear equation, how to find out a row reduced echelon form and how to do elementary transformation. We have discussed all those things. So we are going to use that. If anybody hasn't watched the video of previous one, haven't watched, just go to that video and go through all the concept of rank, and then you can see this video. That is system of linear equation, non-homogeneous system of linear equation we are going to study today. But let's just do a quick revision that what we have studied in rank. So what is a rank? Basically, if I'll talk about rank of a matrix, we have discussed that if we have a matrix A, then what would be the rank? Number of non-zero rows in a row reduced echelon form, number of non-zero rows in a row reduced echelon form, that is by rank of a matrix. And we denote rank of a matrix, rank of A, we also write down it as rank of A. That this row we use to denote rank of A. And we are going to solve system of linear equation using rank of a matrix. Okay, so first let's understand that what is system of linear equation. So when I have more than one equation that are in linear format means the powers, the variable power would be 1. Right? So let's suppose if I have an equation a1x plus a2y, or let's say a1x plus b1y plus c1z is equals to u1, a2x plus b2y plus c2z u2, a3x plus b3y plus c3z is equals to u3. So this is a kind of a linear equation, system of linear equation. That means all the variable x, y, z, we have 3 variables in this system and all variables power is 1. So that's why it is linear equation, and we have 3 equations here. So we can have n number of equations, n number of variables, we can have anything, m number of variables, n number of equation. So whenever all the variables are in linear power and I have number of equations given corresponding to that, I'll say that it is my system of linear equation. Now in this non-homogeneous system of linear equation, when I'm going to talk about that, I am just focusing here to find out the solution of this system of linear equation. I want to find out solution of system of linear equation, but the question arises that what are the types of solution? Do I need to just solve the solution, or is there different types of solution? Let's discuss that. So when I say that types of solution, we'll see 3 examples. Let's suppose x plus y is equals to 1, x minus y is equals to 3, right? And another equation we have here is x plus y is equals to 1, 2x plus 2y is equals to 2. This is first system, this is second system, and another system we have here is x plus y is equals to 1, 3x plus 3y is equals to 4. So I have here 3 systems given. 3 systems here I have. ठीक है, ये थोड़ा ठीक है, इसको ऐसे रहने देते हैं, सीधी लाइन नहीं आई है, हाँ अभी ठीक हो जाएगा. ओके, now it is fine. Now I want to talk about solution. So when I have 2 variables, I can simply use substitution method. The problem arises when I have more than 2 variables. How to solve? But first let's see. If I try to solve this x plus y is equals to 1, x minus y is equals to 3, I'll find out x from here, that is 3 plus y from this equation, and I'll substitute in this equation x plus or 3 plus y is equals to 1. So on solving, 2y is equals to minus 2, y is minus 1. and x would become 2. So x is 2, y is minus 1. When I try to find out solution here, what would happen? I'll find out x from here. X is equals to 1 minus y. I'll substitute here. 2 into 1 minus y plus 2y is equals to 2. So 2 minus 2y plus 2y is equals to 2. Get cancelled, 2 is equals to 2. So that means I am not able to get a single solution here. I get here 2 is equals to 2. So in this case, I get unique solution. I get the value of x2 and y minus 1. So we say that it is my unique solution. Unique solution. And in this case, when x plus y is equals to 1, I have solved that 2x plus 2y equals to 2. I get to the position that I get 2 is equals to 2. I am not getting any contradiction, but I am getting 2 is equals to 2. I am not able to further solve it. So if you would see one thing, that it seems to appear we have two equations here. It seems to appear we have two equations here, but this equation is completely dependent on this one. I'll multiply 2, I get this equation. So it seems to appear we have two equations, but in general we have independent equation is only one. And if we have one independent equation, so what would happen? Let's suppose we have only this equation. That means one variable is free variable. Because to find out two variables, I know that I need two equations. But if I have one equation, I will not say ki I'll not be able to find out a solution. I'll say that one variable is free variable. Out of x and y, one variable is free variable. So let's say I'll take free variable. I can take anything, 1, 2, 3, 4. So I'm taking it here as k. If y is k, x would become 1 minus k. So that means this system of linear equation has infinitely many solutions. Infinitely many solutions. So we get infinitely many solutions when we have a free variable. When we have a free variable, we'll get infinitely many solutions. Infinitely many solutions. We get infinitely many solutions. You can see that you would substitute k1, you would get x0, you would substitute x0, you would get x1. So you would get different values for x and y here. So we'll get infinitely many solutions. Now here comes this set x plus y is equals to 1. I'll find out x from here. 1 minus y, I'll substitute. 1 minus y plus 3y is equals to 4. So we'll get 3 minus 3y plus 3y is equals to 4. 3y get cancelled, 3 equals to 4. Would it be possible? It would not possible. So when I get any contradictory situation, because we know that 3 is not equals to 4, but we got 3 is equals to 4, which would never be possible. And if it is not possible, then how I can say that it has a solution? So that means these two equations contradicting each other. Because it is saying x plus y is equals to 1, and if you would take 3 common, it is saying x plus y is equals to 4 by 3. This can never be true. So this type of equation have no solution. No solution. So in general, we have three types of solution: unique solution, infinitely many solution, and no solution. So you would say that, ma'am, okay, we can easily find out the solution using substitution method. Then why you are teaching us in matrices? What is the use of matrices here? When we have two variables, it is easy to solve. But let's suppose if we have three variables, let's suppose the equation would become x plus y plus 1 z is equals to 4, x plus 2y plus 3z is equals to 7, 2x plus y plus 5z is equals to 6. We get this equation. But you can see that now it gets really lengthy to solve it. First you would find out x from here, and you would substitute in this equation and in this equation. Now your equation gets changed to y and z, and then you have to substitute y and z. So it really gets lengthy to solve it using substitution or elimination method. So when we have three variables, or we have more than two equations, we generally use matrices to solve system of linear equation. But the question arises that how we are going to solve using system of linear equation. So how we are going to solve system of linear equation using matrices. So let's see to that. So this is a general format I have written for system of linear equation. It has three variables, 3 equations. It can have n number of variables, it can have m number of equations, there is no restriction on that. But if I have 2 variables, I can simply solve it using elimination. If I have more than 2 variables, then I'll switch to matrices, right? So what would I do? I'll write down first it in matrix format. What would I do? I'll take all the coefficient matrix A1, A2, A3, B2, B3, C1, C2, C3, and here I can write down XYZ, and here I can write down U1, U2, U3, right? I can do that. Now if you would see, you can if you would check here, A1x plus B1y plus C1z equals to U1, you would get first equation. A2x plus B2y plus C2z equals to U2, second equation. A3x plus B3y plus C3z is equals to U3. So you would get your system of linear equation. Now you would represent this matrix as A, this variable vector as capital X, and right side as B. Ax equals to B. So we get our system of linear equation as Ax equals to B. So we have, like at the start we have said that we have 2 types of system of linear equation. I have mentioned non-homogeneous, but we have 2 types of system of linear equation. One is homogeneous and another one is non-homogeneous. Homogeneous and non-homogeneous. Non-homogeneous. When it would be homogeneous? When the system of linear equation is homogeneous, when the right side, the B vector you have taken, is completely 0. That means U1, U2, U3, all 3 values are 0 here, then it is homogeneous. If any one of the value is not equals to 0, then I'll say that this B vector is not 0, then we have non-homogeneous system of linear equation. So first we'll solve non-homogeneous system and then we'll move to homogeneous system of linear equation. Now to solve your system, Ax equals to B, using system of using matrices, you first have to write down one more thing here, that is augmented matrix. Augmented matrix. And what would be the augmented matrix here? Augmented matrix, you have to write down A augment B, right? A augmented B. What is your A matrix? You would write down A matrix is A1, B1, C1, A2, B2, C2, A3, B3, C3, and augmented vector would be U1, U2, U3. So this is your augmented matrix. This is your augmented matrix, A augmented B. This is your A matrix and this is your B matrix. Using that, we'll solve system of linear equation. Basically, we are going to find out either we have a unique solution, infinitely many solution, or no solution, right? Let's see to that. Now, so if I have this system of linear equation, I can write down here it in the matrix. Here A would be 1, 1, 1, 1, 2, 3, 2, 1, 5, and B would be 4, 7, 6. If I need a augmented matrix is A augmented B would be 1, 1, 1, 1, 2, 3, 2, 1, 5, and the right side would be 4, 7, and 6. This would be your augmented matrix, A augmented B. Now, let's get back to system of non-homogeneous system of linear equation, solution of non-homogeneous. So we have said that we have a system Ax is equals to B. Now I have to discuss about 3 types of solution. So we know that this non-homogeneous system of linear equation has 3 types of solution. So what are 3 types of solution? First we have is unique solution. Unique solution. Another one we have here is infinitely many solution. Infinitely many solution, and another one we have here is no solution. When the system has unique solution, the system would have is unique solution if you would find out rank of A augmented B is equals to rank of A is equals to number of variables. If all three things are equal, then you would have a unique solution. So you would find out your rank of augmented matrix, you would find out rank of A, and you would see how many variables you have given in the question. So if all these three values are equal, then we have a unique solution. Infinitely many solution, when rank of A augmented B is equals to rank of A but less than number of variables, then we'll have infinitely many solution. And also you can see that in infinitely many solution you would have a free variable, if you would have a free variable. And how you would get a free variable? Free variable is nothing but number of variables. अभी हम इसको थोड़ा और डिटेल में डिस्कस करेंगे when we'll solve questions. Free variable is nothing but number of variables minus rank of A. That would decide that how many free variables you would have in a question. Next we have is no solution. We'll have a no solution when rank of A augmented B is not equals to rank of A. Then we'll have a no solution. Right, if this thing gets equal. So we have three types of solution: unique, infinite, and no solution. The system would have a unique solution if rank of A augmented B equals to rank of A equals to number of variable, and infinitely many solution rank of A augmented B equals to rank of A less than number of variable. No solution rank of A augmented B is not equals to rank of A. So here I have written one matrix, this one A augmented B. इसकी rank find out करते हैं. We'll see that कितने solution है this system of linear equation we have written. So let's find out rank. So for that, first I'll row reduce. So we know that first row reduce would be R2. Row reduction we have already discussed in the last lecture. So now you know how to find out row reduction. What would you do? R2 tends to R2 minus R1. R3 tends to R3 minus 2R1. What would I get? This A augmented matrix would become 1 1 1 4 0 1 2 3 0 minus 1 5 minus 2, that would be 3, and 6 minus 8 minus 2, right? This would be the, is it in row reduced echelon form? No, you should have to make this value 0 as well, this value 0. So what would I do? R3 tends to R3 plus R1. R3 tends to R3 plus R1. So what it would become? 1 1 1 4 0 1 2 3 0 0 3 plus 2 5 and minus 3 minus 2, that would be 1. Now one thing if you would notice here, that rank of A augmented B, this is in now row reduced echelon form. Rank of A augmented B, from here I got rank of A augmented B is 3. Now I need to find out rank of A. Now for rank of A, do I need to row reduce A matrix again? No. What you would do? You would just look at this matrix leaving this right hand side vector B. Right? You would not look at it, this B vector, and you would get rank of A. What would be rank of A? You would look only this matrix. Okay, how many non-zero rows? Rank of A is 3. So now here you would notice here rank of A augmented B is equals to rank of A is equals to 3 number of variables. So it would have unique solution. And how do you find out a solution? Right, that is also a question ना. So what would you do? यहाँ से शुरू करो नीचे से, मल्टीप्लाई करते चलो, whatever we have coefficient matrix just multiply. 0x 0y 5z. 5z is equals to 1, so z would be 1 by 5, and this would be y plus 2z is equals to 3. Z I got as 5, 1 by 5, so 3 minus 2 by 5. So if you would solve 3 minus 2 by 5, 5 3s are 15, 15 minus 2, 13 by, just a minute, 13 by 5, and the last equation is x plus y plus z is equals to 4, right? I got this x plus y plus z is equals to 4. सो अब इसको सॉल्व कर लो. 14/5, y को रखो 13/5, z को रखो 4/5. So I think you would get it as 6/5. Right, so I got the answer, and you can just satisfy all these values, you would get the result. Instead of doing it in your substitution or elimination method, this would get you correct answer. Correct answer उससे भी मिल जाएगा, but like this would not get as much lengthy as your elimination and substitution process. And substitution and elimination process can take time to solve, but it is not much lengthy as compared to that. And there are chances of having mistakes in elimination and substitution method. Okay, so that's how we solve non-homogeneous system of linear equation. Let's see some questions. So this is a question they have asked in GATE CS 2005. So what they are saying, consider the following system of equation in 3 variables, x1, x2 and x3. This system of equation has no solution, unique solution, more than one but a finite number of solution, infinite number of solution. One thing you would remember, that when they are talking about system of linear equation, only we have 3 types of solution. There does not exist any case that more than one but finite number of solution. There would not any case like this exist. We'll come to that in homogeneous when there are independent solution, like they would talk about independent solution, then we'll discuss that. Right, but right now here, what would be your system of linear equation? You would write down your augmented matrix, A augmented B. A is your coefficient matrix and B is your right side matrix. 2, -1, 3, 3, -2, 5, -1, 4, 3, and right hand side would be 1, 2, 3. Now I have to row reduce it, but before row reducing, can I interchange first and third column, because there would be a 1 and negative of 1, but that would help us to get next to row 0 easily. So I am doing there R3 tends to R3 interchange with R1. I got the matrix -1, 4, 3, 3, 2, -1, 3, 1, no, sorry, 3, -2, 5, and this would be 2, and 2, -1, 3, that would be 1. Right, there would not be, this is just the elementary transformation. Now you would make this 3 and 2 0. So R2 tends to R2 minus R2 plus 3 R1, and R3 tends to R3 plus 2 R1. Let's solve it. What you would get, -1, 4, 3, 3. This would become 0. 3 4s are 12. 12 minus 2, that would be 10. 3 3s are 9. 14. 3 3s are 9 and 11. And this would be 0, 7. And 2 3s are 6, 7, 8, 9, 7. Right, we got these values. Now I have to make this 7 0. So to make this 7 0, can I apply R3 tends to R3 minus 7/10 R2? If I'll solve this, -1, 4, 3, 3, 0, and this would be 10, 14, 11. This would be 0, 0, 9 minus 7 4s are 28, 7 1s are 7, 8, 98/10, -8/10. एक बार कैलकुलेशन गाइज एवरीवन वुड चेक बाय योरसेल्फ, चेक कर लेना कैलकुलेशन. -77/10, वी गेट दिस वैल्यू. नाउ यू कैन सी दैट, एक बार कैलकुलेशन सब लोग चेक कर लेंगे. नाउ इफ यू वुड सी हेयर, वी आर गेटिंग, व्हाट इज रैंक ऑफ A augmented B? Rank of A augmented B is equals to 3. Rank of A is also 3, and number of variables are also 3. So how many solution we have? We have infinite number of, oh sorry, what I'm doing, we have unique solution. we'll have here a unique solution, and they are not asking us to find out a solution, so we'll not go into that. Otherwise, if they would ask to find out a solution, then I'll find it. Right, now let's see next question. Next question we have here is, how many solution does the following system of linear equation has? This is again a great question. Now in this question, if you would see, they are saying it has infinitely many solution, 2 distinct solution, unique solution, none of these. I told you 2 distinct solution जैसा कुछ नहीं होता है, either it has infinitely many, or unique solution or no solution, right? Let's try to solve it. Now it is in 2 variables, so now it's up to me, either I have to solve it using row reduction or I can solve it directly using substitution, but generally I'll solve directly using substitution when I have 2 variables. So if I'll find out, what would I do? I'll find out x from here. X would be -1 minus 5y, और एलिमिनेशन यूज कर ले, वो ज़्यादा ईजी रहेगा. -x plus 5y is equals to -1. x minus y is equals to 2. If you would solve, x and x get cancelled, you would get 4y is equals to 1. ऐड कर रही हूँ दोनों को ना. y is equals to 1/4. x को यहाँ, y को यहाँ पे सब्सटीट्यूट कर दो. x would be 2 plus 1/4, 9/4. ठीक है, x 9/4, y 1/4. बट ऐसा नहीं है कि 2 इक्वेशंस है, आई विल गेट अ सॉल्यूशन, सो माय वर्क इज डन, बिकॉज सिस्टम हैज ऑल 3 इक्वेशंस. सो आई जस्ट हैव टू चेक दैट आर these 2 values satisfying this equation as well or not. If they are satisfying, then we'll have a solution, otherwise we do not have. 9/4 plus 3 into 1/4 equals to 3. So you would check that 9, 10, 11, 12, 12/4, 3, 4 3s are 12, so it is satisfying. So that's why we'll have a unique solution, right? We'll have a unique solution. And I also show you that if I'll use row reduced in this 2 variable, what would happen? -1 5, -1 1, -1 2, 1 3 3. I told you that there is no problem that I have given any number of variables and any number of equation. Like here we have 2 variable but 3 equation. That there is not a problem. The condition only I need to satisfy that rank of augmented matrix, rank of a matrix is equals to number of variables. So I'll apply R2 tends to R2 plus R1, comma R3 tends to R3 plus R1, right? So what would it become? -1 5, -1 0, -4, no, it would be 4, 1 0 8 2, right? Now I'll make this 0. R2 R3 tends to R3 minus 1 by minus 2 R2, -1 5, -1 0 4 1 and 0 0 0. Now you can see that rank of A augmented B. What is rank of A augmented B? Rank of A augmented B, number of non-zero rows, that is 2. That is also equals to rank of A and equals to number of variable as well. All 3 values are equal, so we'll have a unique solution. ठीक है, you can either solve it using row reduced echelon form or matrices, or you can apply elimination method if we have 2 variables. But if we have more than 2 variable, then it really gets lengthy to solve it using elimination and substitution method. So guys, that's all we are going to discuss it today. We are going to discuss more questions based on non-homogeneous system of linear equation in the next class, and then later on we are going to start homogeneous system of linear equation. And guys, once again I'll tell you that before looking at the solution, just try by yourself, pausing the video, just try by yourself, right? Then you would get to know that you are able to solve by yourself or not. Then you would solve, then you would look for the solution. Okay, so yeah, these are all the topics we so in this you have to understand, you have to remember this. You just either take a screenshot or I'll share a file as well. But you would remember that this rule would be helpful for later on questions. And this thing, free variable thing, because in today's lecture we have solved 2 questions based on unique solution, but we are coming to all the different types of solution in the next class. Okay, so we are going to solve more questions based on that. So if you feel like you have any doubt, you can just let us know in the comment section. We'll be happy to help you. Okay, so that's all for today's lecture. Thank you guys. Thank you for joining.